Okay, so let's start again. Thank you for coming. And also the reminder I was saying is that there is a survey to, we are asking if you prefer to change the time of the seminar to the morning. So there is a public survey where everybody of Medea should vote your preference. That is basically to keep them in the afternoon, Friday afternoon, or to move them to Friday at 12. So please vote because we need the opinion of most people better. Now I think that only 30 people have voted, but I think we are many more here. So please check it in the bulletin, this survey. So yeah, enter and it's just clicking your preference. Okay, so let's start with the seminar. Today we have Amaya Álvarez. She is a postdoctoral researcher in the MARES group, and she's specialized in applying deep learning techniques to fisheries research. So I guess it's what she's going to explain. So thank you very much, Amaya.
Thank you. First of all, thank you to all of you for taking the time to come into this talk, especially for the English speakers that make me speak in English, which is really amazing. And the title of my seminar is Deep Learning Inside the Fish with H, because I like it, inside the fish market. And as Eneko said, I'm working in the MARES group, specifically in the Fish Ecology Lab, and in this presentation, I will show some of the works that we've been doing in the fish market since 2018. And all of them were mainly focused on obtaining in an automatic way the size or the length of the fishes. Okay, so what has to do the deep learning and the fish market with the Fish Ecology Lab? Well, first of all, the fish length is a key element of the ecological growth models. So we need this information for knowing how the stocks are going to be next year, how is the environmental changes affecting these stocks. But this variable, the fish length, it's not easy to measure in underwater with alive fishes. So traditionally, it has been measured on board in the fish boats or in the fish market. So this takes like a lot of it's labor intensive, and it becomes in a scarce variable. So we don't have a lot of this type of data. What has happened in the last decade is that first the fish market has implemented video camera systems in their conveyor belts to have a better view of the boats that they want to sell. And also new techniques like this deep learning technique has become a really good way to obtain information from the images. Here you can see the traditional measurement of a fish length in the conveyor belt. And this is the conveyor belt of the fish market of Mallorca, and above this, there is a camera that is pointing all the, taking pictures of all the boxes that comes through that. So before we start with the fish market, a quick reminder about what is deep learning. I'm not sure if all of you know a lot, but I will just give a little insight into the deep learning, which it's part of it's a subfield of the machine learning, all inside the artificial intelligence field. This subfield, it's based on learning different higher representations that come from lower level concepts like a straight, a curve, or things like that. So the deep learning technique is used on images, sounds, and languages, but we are using it only on over images. And normally it's used by the algorithms of neural networks. This is a typical architecture. It's just to show it. I'm not going to explain it. And what we can obtain from the images by using deep learning is a classification of each image, or the detection of objects inside the images, or even the segmentation of these objects like these ones. There's a difference between instant segmentation and semantic segmentation. We only work with instant segmentation that give us the different objects inside an image. So why can we work with these images? Because since 2019, the fish market of Mallorca has a camera, and we here at IMEREA, we are storing these images, all the images that comes daily, which are around 800 and 1,500 boxes per day. So we also have the metadata related to these images that include information of the boat ID, the total weight of the boat, of each boat, and the commercial category. Those are the metadata. You can see here, for example, the weight or the species, which is octopus in this case. And these are like the kind of files and folders that we store here at IMEREA. So we already have 4 years of information. And what do we want to extract from these images? Well, what we want on the projects that we have been doing is mainly the length of the fish, but also the number of fishes inside each box and the species that are inside some of the box that come mixed with mixed species. Here you can see this is a typical box here in the fish market. It's called Variat, and it comes with like 5, 7, or even 15 different species. And so we have, those are images from the conveyor belt auction. We have all the species that we've been working with, the dolphin fish, which is the Yampuga, the Zeus faber, which is the Gallo San Pedro, and the Mulus submuletus and Mulus barbatus that are the Salmonete. On our first project in 2018 called Photopaste, we were supposed to extract the length of the head, Merlucius. And we were supposed to do it by using the images from the ports, from the fishing ports. At this, in 2018, the conveyor belt camera wasn't already set. So we tried to use images that came from the stations that the local government has in every fishing port. Those are the type of images that we decide. You can see that they are useless. This one was not the best. So after 5 months of project, we decided to go to the fish market and put a camera on the top of the conveyor belt. In this case, this place is also the place where they weigh the box. So you can see here some images, typical images of the head in the conveyor belt. In image A, you can see the only one where we will be able to extract the total length, but the typical images are the B and C. So you can see that there's not possible to have the total length of neither of the fishes inside the box. But what the feature that we thought it was visible was the head of the head that was almost for all the fishes inside the box visible. So we look for a feature that could be segmented and used inside the deep learning. And we decided to define the head as the length from the pelvic fin to the top of the mouth, like this. No? So you get the 2 points of the pelvic fin and the top of the mouth. This is a segmentation done in one of the boxes with using a software of annotation that it's like there are thousands of them. And just this is a tip for people who's thinking about using deep learning with a data set here. The annotation is the most time-consuming part of this of the technique of deep learning, and you have to be really careful about what and how are you annotating. So it's better to spend time in choosing the images you are going to use for your training and how are you going to annotate them. About how many images you should annotate, this depends on lots of variables like what you want to get, if you want to classify, if you want to segment, or how is your image composition. Are there many objects? There's one class, there are many classes, like different species. So you will never know if it's enough, the amount of images that you have done. In my case, in this first project, we labeled 200 heads, which is about, I cannot remember, but it was like between 60 and 100 images. And so I beg you not to ask about this because it's been a while, so I cannot explain all the diagrams that are here. It's just the architecture of the deep learning neural network that we use. And I post this slide just to explain how we ended up using deep learning in a project that didn't have this technique inside the proposal that was first written. When the proposal was written, this neural network wasn't published yet. This was published on March 2017, and the implementation that we used was released November 2017. So we used just the newest technique that was available, and we use it because we were looking into the bibliography for the traditional visual recognition by computers, and the results with fishes were not really good. So we decided to go for this new technique and see what could happen. This is a typical neural network. Those are the architectures of different neural networks, but the most commonly used is this, which is called convolutional neural networks, but it's not really important here. So once we had decided this network and we trained it, we obtained our results. I'm going a little bit fast because I want to explain two other projects. And what we achieved at the end was a system that allowed us to, by extracting the heads of each box, all the heads that were useful for extracting the total length, we make a relationship. We extract the relationship between the total length and the head length, so we could at the end obtain a median size of the heads within each box. So we didn't get all the size for all the heads, but just the median size of each box. This is always assuming that the size within each box is more or less is similar. There is no big variance. So we publish this project and we get the next project was a continuation to keep improving this system. And we changed the species to the Yampuga, and we also wanted to make some other tests with other networks to see if we were able to classify species inside different boxes and classify two really similar species, which are Vulus and Vulus ungulatus. We didn't have enough time, so I'm only going during the project. So we made this test, but we didn't deep into these studies really far. So I'm only going to explain what happened with the Yampuga. Here you can see a segmentation of different yampulas inside the box. And you can see that we can have the total length. But the truth is that this is not a typical box of yampula. And normally, currently you cannot see all the yampula body. Instead of that, you have the yampula like this, so it's overlapped with the others. So you don't really get all the information for the length. So we need to find another way of extracting information from these boxes. Those are the other, we keep going with master CNN, and we also use other deep learning techniques like RetinaNet and BGG, but this is so what we did with the yampula, instead of trying to relate any feature of the body with the total length, as we already had information from the metadata of each box, we had the total weight of the box. So assuming again, which is not far from reality, that inside each box of yampula, the sizes are really similar. With this assumption, we thought that it would be possible to infer from deep learning the total number of yampulas that were inside a box. Once we had this total number, we could divide it, the total weight, into this total number and obtain the weight of each of the medium weight for each of the fishes. So this scheme explains how the box arrived to the box the yampula fish arrive to the conveyor belt, its weight and its photo is taken, and then comes to IMEDEA to the database. And here we use the weight information from the box and the number of fishes extracted from the deep neural network trained. And so we get an average fish weight, an average fish length, and finally the estimation for a given box of the median length of the fishes inside this box. This is a confusion matrix. In this case, for the yampula, we had this confusion matrix explains the information obtained from the deep learning training. So in this case, we obtain an 80%. We could say accuracy. It's not exactly accuracy, but let's say it's more or less like the accuracy of how well is working this network. And this information over there is like the final product of this project, that was a weekly newsletter that we gave to the fish market for them to know how was evolving the size of the yampula during the season, the fishing season, which goes from September to October. And I don't know what time is it, but finally, from these projects that went from 2018 to 2020, here, well, 2022, it's because we have made other projects, not inside the fish market, but with deep learning in underwater image or with underwater images. So what we learned there mainly was the importance of having a really good data set for the training. Like, it's really, like, yeah, it's the most important thing to be really careful choosing the images you want to use for training. It's really important knowing how do you want to segment, or if you want to do bounding boxes, and to create a good data set. If you have a small data set, which I guess here is what everybody has, because even you have thousands of images like we do have now, you don't have enough people to start annotating. And so you end up having a really small data set for training. This is, you can train with a small data sets, it works, but you need to be really careful about how you segment, for example, which makes really difficult to share this work with other people, because if you need to be really constant with the things you are segmenting. If you decide to include the tails, but just with a little bit more or this matters, so you need to be constant. And it's difficult to share this work with many people. And now, if you allow me, I would like to present the project we are now currently working on. And as this is a presentation I should be doing in 10 days in a Congress, well, it would be like a rehearsal. So please feel free to point out all the things that you find that could be better or that are wrong. I think this title is okay. So, but anything you see or you think that can be improved, just let me know, please. So here I go. I'm going to explain to all of you this work that it's called automatic extraction of red shrimp size and caliber from auction images. This work, it's been done in Mallorca Island, in IMEDEA Spanish Research Institute, which is located in the Western Mediterranean Sea, in the Balearic Islands. We are working mainly focused on extracting information of big data set images from the fish market auctions. And so we are focused on the species Arypteus antenatus, commonly known as red shrimp. This species has been fished in Mallorca, in the Balearic Islands, the last 70 years by the troll fleet. And it's what a pity. Okay. So I have what we usually use with these species is the cephalothorax length, which goes from the A till the last part of the caparas here. And you can see an image of a onboard sort of boxes. Usually the red shrimp is sorted by size, because size increase, the bigger the shrimp, the higher the price. So boxes are really well sorted in order to get a better price for each box. In Mallorca, there is only one fish market, and this fish market goes with 80% of all the fisheries, of the commercial fisheries that goes through the Balearic Islands. Here I present two graphics about how the price it's distinguished between different categories of the red shrimp. In this fish market, they have 5 categories. The extra, which are the bigger ones, you can see that they are really well sorted inside the box. Then the large, the medium, small, and finally a category where the size is mixed because it's all the shrimps that are broken. It must be said that the look of the shrimps are so important at the time of the sailing. So you can see that the extra with the blue gets the higher values, and it's the value is depending on the season. Like, for example, Christmas, it's a higher price, or August is when the prices are higher, and also the meteorological conditions. And you can see in here the average price per box and by caliber between 2021 and 2023. And you can see that the price for the extra, it's nearly 3 times the price for the small one. So yes, it's a big deal knowing the size, and even better knowing the size of how many shrimps are inside each kilo of each caliber. Actually, these calibers are done by the fishermen who subjectively say if they are extra large or medium. So trying to obtain an objective value becomes important for the fish market commerce settings. This table is just to show how the fishery of the red shrimp has decreased the last 20 years, has gone to the half of the tons that were, those are the tons fish Mallorca Island, and it has gone to the half. This is because mainly it's due to the reduction of the effort of the fisheries effort. So what it means is that the boats go less days than they used to go for the fish of red shrimp. The objective of this project is to retrieve the median size of the red shrimp, if possible, inside each box at the ocean. So as you have seen, it's not really easy to see each of the streams. So it's kind of challenging trying to obtain any kind of information, mainly the number of streams that are inside of this box or this box. This is the best one because you can see all the streams. You cannot see all the body in most of them, but some of them, yes, do show all the body. So maybe these ones that are really well sorted are the better ones for working with deep learning. But again, going again with the objective, why is it important to obtain the size? Well, as I said before, here we have two points of view. The ecological one, which is again like the key, the size is a key element for the ecological growth models, and then there's the fish market interest, because they want to have an objective way of measuring splitting the calibers of the red shrimp, just to better control the price or even to arise them. Those two graphics, well, there are quite a few studies about red shrimp in the Mediterranean Sea and in the Western Mediterranean Sea also, and they all have surveys about relating the weight and the cephalothorax length. These two graphics are not from our surveys, but from a survey done in an area near the Balearic Islands, which represents the same species. And it's just to show the difference between female and male, and let you see that females are bigger, larger, and then heavier, and that the male distribution finished nearly 35 millimeters of capillary length. And so it means that most of the bigger, if not the majority of the bigger shrimps are females. This species is distributed between 200 meters and 2,000 meters depth in the big slopes. And it's maybe the first in economical importance inside the fish market, talking about crustaceans. Well, having in mind our objective of extracting some kind of information about the size inside the boxes, we implement a methodology that was sampling boxes of each of the commercial categories and measuring the weight and the cephalothorax length. As we are not going to be able to see the sexual difference inside with the images, we didn't split the information in our surveys. We also create an image database with the images that we took on the auction. Those are the same that were sampled there, and we identified each of them. This is the string number 1, number 2, and we make different photos in different positions in order to have a database that could be used for extracting information inside the about the relationship between features that you can extract from the deep learning and weight or length information. And finally, what we had to do is to explore the images to identify any feature that could correlate with the weight or the length. So we tested different features. Here you can see, this is the first feature we tested. As you can see, it's all the streams are segmented, including these dots that are the background. This segmentation is done completely automatically. You just point here, click, and by using a new model called Segment Anything model that was released by Meta in 2023, it gives you like really quick and really easy all this information. Really nice, but for the stream, it's not working. This one is it's only the abdomen area of the stream. We were trying to see if the relationship between the abdomen area and the weight or the length was a good relationship. And finally, this one, the one that we picked, is the whole body taken out the legs and the antennas of the stream. Well, to know these, to test these different areas, we first took all the information about all the streams that we surveyed. We had like 146 streams, so we get this relationship between the weight and the cephalothorax length, and then we try to make the relationship between weight and area and segmented area for the different features, and length and segmented area. Here I'm only showing the relationship between weight and area, because the length area, where these are really worse, these are really bad, but the other ones were worse. So and the difference between straight and curve talks about this difference, like measuring in a position really straight or in a curved position. You can find inside the boxes these two positions, mainly these two positions. So we were trying to see the difference. It always was better, even though they are really bad numbers, always was better with the straight strings. Those three are the three that we didn't use. We keep with this kind of images, which gave a better relationship. Not really good, but it was better, and it was the only one that we had. So the image that after having this information, so we already have this data set with different images of the different categories, or in this, we know all of them. We have all of them. We know that this is the number one, the number two. So we know everything about these streams. And we have different images of each stream with different positions. So we can get different area values for the same stream. But we also have the other data set, the daily data set collected since 2019. So we could use this information as well. And what we did was creating for the training a big data set with images coming from the daily data set and the images obtained in the surveys. In this case, we use the YOLO the YOLO neural network. I don't know if you have heard about that. This is the You Only Look Once. It's been working really good since the first version. And the good thing about the 8th version is that you can segment. Before, it was not possible to segment. This YOLO number 8 was released in January 2023. And today, there is YOLO version 8.1 already with better things. Just to point out that you will always find this when working with deep learning. When you have some results, you know that there is a better neural network that you could be using. So maybe it's better to start again or not. You don't know. So what we did with this YOLO was to train with 75 images that have two categories of streams. Those in purple are streams that are not useful for measuring, and those are useful for the measuring. And so we get, at the end, we have like 2,000, yes, like 2,000 streams segmented for the training. We train like for 200 epochs, and just for you to know, here you can train. We have a server that is really useful and it can be used for this type of trainings. And well, I encourage you to try to use it because you will get good results. So we use this YOLO neural network, and we obtained these results for the validation. Here you can see the images that you can obtain with YOLO. Those are like the system says that all of these are streams that are useful for measuring. So you can use all of them for measuring this box. But in this one, it says that there are the red ones are the ones that are just, yes, the system knows that they are streams, but they are not useful for measuring them. So here you can see the original image and all the segmentation that the system does. Here, the important data is that for the measurable streams, we have a 70% accuracy, 75% accuracy. It's not the best one, but we have to keep in mind that we have like really small data set that we have the possibility to increase it with a little bit more of time, but it could improve. This part of the system could be improved. And now we come with the results of this project. We were supposed to take the size of the stream, or maybe the number of the streams that are inside a box, or maybe the median weight of the streams that are inside the box. And at this day, we have a small problem. Those are the really good results. This is the results obtained for estimate number of streams. These are the estimate number, and these are the true number of streams for a test with the 10 boxes. Not so bad. So you can see it's really nice. Okay, this is really nice. But we have these two. So it turns out, maybe Mikel could explain it better, that we are not pretty sure. This is like going with the optimistic statistical analysis. And this is going with the pessimistic one. It's not really bad. You can see that you will say, well, you say like you have like 40 and here you can have 50 or 30. But if you use the information of the real data, like trying to compare the number with real data, you get more or less the same confidence interval. So it's really close even with this information, and we don't know if we can use these ones. Maybe, but we start thinking about, I have 1 week to know. So I cannot really give you any results because we're still working on it. So in my conclusions, I have to apologize and say that I am still working on it, and maybe next week you can ask me and maybe I have something to say. So thank you very much.
For 20 questions. Was there a reason why you didn't pick the egg for the Yampuga like you did for the egg?
I didn't pick the,
Yeah, just mentioning that.
because in the, if you look at the images of the Yampuga, you cannot really see the head nor the tail. They are like, they are sorted like files or like envelopes. So you only see a little small part of the fish. So you cannot take any information of the length with the part that you can see. So we needed to change and going for the number.
So the way they pack them depends depends on the species or.
Depends on the species. Yeah, each species is it's sorted in a different way.
I have a question because you have shown us the problems getting the true size or the weight of the individuals that are in each box. I was wondering if you have the same problem when something that you said that maybe were one of the goals of the first project, but later you didn't continue with that, is identifying different species, like estimating diversity in the boxes, number of the species and number of individuals of each species. Do you think that if you try, your goal is to obtain a measure, an estimate of the diversity of what is going through the fish market, this methodologies would work better or would have the same progress of estimating the size of the?
No, well, for classifying using a different neural network, it works. Like, yes, they would be better because of the difference in between species, but it's depending. Like we tried with Mulus surmuletus and it didn't really work. It worked like more or less, but with Mulus surmuletus and Mulus barbatus, the species were like, I couldn't see, I didn't know how to differentiate. I went to see a person that could differentiate them, and he on the image, he couldn't differentiate the species. So it depends on that, but the type of images that we have with different species, as they are really different. And I've been working in the same project for the shrimp. We are working with the images of these, and it's working pretty well. I have I can separate them easily, but this was in 2019. Now I have used a different network and it's working pretty well, but you still have the kind of problem with overlapping you will never have, but you will never do anyway. So we work here with having lots of boxes, and like the error, it's going out because you have like so many images. So you can discard the images where you cannot see all the information because you still have a lot of images. So you will get a good result about the median information of the fish auction of this day, of the day, puntual day, I think so. But you will still have problems like overlapping that you cannot see all the information inside the box.
You know, I understand that you will have problems with overlapping and how they are placed, the species or the
Yeah.
But I was wondering if it would be easier to estimate diversity than estimate.
I think it's easier.
Fish size.
Yeah, I think it's easier. Yes.
Yeah, well, thank you for the seminar. It's very promising. Now, just a curiosity, you're trying to estimate the size of the shrimps from the image, but you have a very wide correlation between weight and size. Wouldn't it be easier to weight the single shrimp?
You have to go there and wait.
No, but you can automatize the way to weight the shrimp, no?
One string. How would you automatize weighting?
Or if you do it with the boxes, you can do it with.
Well, I think it's like it's really different because they put all the shrimp
No, I
inside.
mean, if you weight it automatically in box, or it's not.
Yeah, you weight automatically the box. So
Yes.
you have like for the small ones you can have 200 shrimps inside one box.
No,
So
I don't know.
no, but they do it. They actually do it. Like they actually have like be monthly or they have measurements of the streams, but it's like a small slot manual, but it's a small slot.
No.
So again, with that, maybe you don't get this refinement in your measurements, but what you get is a massive measurement that allows you to discard information that you think is not really good. So you can have like boxes well sorted, and you can just go for these ones and say, I'm pretty sure what I'm measuring is okay because I can see everything and I can. So you can just go. The neural networks also give you a confidence level about each inference that they make. So you can just put a threshold really high and say, I'm not going to go under 90% of confidence level. And you will get like a small number of boxes per day, but it doesn't matter when you have everyday boxes. So you will get at the end, the big picture you will have really well explained. Maybe not a refined, you don't get the small things, but you will get a good big picture of the fishery, of the red streak, for example.
But I think what you're asking is why not extracting the weight instead of the size, but this is what you are doing exactly.
No, but he's asking about weighting it.
Yeah.
Like, really weighting.
Whether it would be better to put the system to weight each check.
We wait.
No, but the system, the deep learning system.
No.
No, yeah, you cannot. How do you do? You need a machine that goes and.
They do it with
But you have a
food, for example, they put in boxes and they have to be always the same, like 200 grams for each box. To do like
Yeah. But you can, I think it's not benefit cost,
Yeah,
will
yeah,
be.
It was just for us.
We are trying to exploit an information that is provided by the sellers. By the seller, by the seller.
Yes.
We can.
No, but it's not.
But of course,
I'm not saying you should.
If anyone wonders, yes, I ate all the shrimps that
Great. Can you explain again the problem with the results? I didn't.
Okay, the problem with the results with the shrimp.
Yeah, the previous.
Sweet. So the thing is, Mikel, not me, he has been working with the statistical model that represents the information that we have. And you can use different distributions in order to obtain a confidence level with about your median values for each. No, because I'm talking about a median value for each box of the weight. And I'm using this information, but this median value goes with a confidence interval no? So this, depending on which distribution you use, will be bigger or smaller. So which one is the better one? We are not the better one, but the one we have to use.
Here, I didn't understand which is the difference between the plot in the top and the plot.
Okay. The figure at the top right. This is the route that each point is a chain. We have measured both the area and the weight. From that relationship, we are able to estimate from the output of the network of yellow, we know the area of a subsample of change from a box. From this relationship, we are able to estimate the weight of each one of the measured change with point estimation used confidence interval. We thus, from this information, we are then able to estimate the average weight of all the change in this box. From that, dividing the total weight of the box by this number in confidence interval, we are getting the graphs in the diagram, in the main diagram. However, they are the estimated number of streams, and this is a real number. So this number should be translated to an inter number. That is what really are measuring the reality. And the problem is how to translate the estimate in the real number estimate to an integral number. And by now we are analyzing how is the relationship, the underlying distribution of the real numbers around the real one. The plot at the left bottom are assuming that the underlying population and assuming that the underlying distribution is a Poisson distribution. It is the canonical assumption. However, we are suspecting that this number, this distribution, the actual distribution is probably on the dispersed. It's some kind of negative binomial. But we are still trying to.
So even you see here, these ones have also this confidence, but here are much better. That's the, so depending on the distribution we are using. So I'm not saying maybe this is the right one. We don't know if this one is the right one. Could be.
But you say that the confidence interval of the estimates is similar to the one of measuring by hand or not? Maybe I didn't understand.
No, this is the confidence interval of the estimation.
Yes, but what about if you measure by hand?
Ah, when I told you this one,
Yes.
yes, yes,
So if
Yes.
these two are similar, I don't see much problem.
yeah. Did you understand? Like this, when we measure by, when we do it by,
And
no, but not segmenting, but just making the relationship between the number, the real number and like using wavelength. Yeah, by hand, you get more or less, it's a little bit smaller, but yes, like here you have like 10, 8, 10, different eight streams over, up and down, and you get like 6, depending on the place you are. Because it depends, yeah, it's not really bad.
And you have a wide confidence interval, but then the average estimated value is quite close to.
Yeah.
It's just one shear, but should some few up and down.
Yeah.
It doesn't seem bad.
But I need this week too.
I mean, is that important to get exact number of things? I think 1, 2 up and down.
Yeah.
Okay, so I think we should leave it here and go for some years after. And please remember to vote.